I'm going to talk about design and development process. Clause number 8.3, ISO 9001 2015. This clause places requirements how an organization shall control its design and development activities. Let's begin. Design and development has been defined as a set of processes that transforms requirements for an object, which could be like a building, like an equipment, like a pen. It could be even, it could be a training service, for example, a training course material. So the process that transforms requirements for an object into more detailed requirement for that object. So the requirements must be far more detailed so that you can produce, or the organization can produce or realize the product that was conceptualized. This definition is defined by ISO. Now, this you will find 3.4.8 means this is the requirement given in ISO 9000 2015 standard. Now, let me explain in a more layman's language. So, design and development is a plan, or design is a plan or drawing produced to show the look and function or working of an object before it is made. So, it's kind of a drawing, it's kind of design calculation. I find this definition is more close to my heart what design and development really means. So this is my definition. So let's look at it. A design and development is a process. Of course, design is a process that converts a concept of or a proposal of an object. Process. That could be process design or a system design, like material handling system design. Okay. Or building automation design, things like that. So it is a proposal of an object, processes, or system into a visual output in the form of drawings, specifications, and bill of quantity. So design output will come with some kind of design specification. You will have drawings, you will have material specification, and all these are output of the design process, including bill of quantity. For example, for a pressure vessel, how much of material is required? What kind of components are required? What is the technical specification? So, useful to give the concept. The vessel is a concept, the building is a concept, into a real, tangible shape or form with a name to satisfy the intended purpose. So I think this is more a realistic definition of design. Basically, there is a concept, you do design calculation, checking, drawing preparation, outputs are coming from the system in the form of material specification, technical specification, drawings, etc., which can be used for further product realization process. Now, I'm quite passionate about vehicles and the cars. I started my career in automobile. My case study for quality management system is based on automotive industry. Let me give an example from automotive industry. So we want to develop a strong, sturdy pickup truck, which is a kind of an SUV, sports utility vehicle, suitable for 5 passengers with double doors, right side 2 doors, left side 2 doors. That takes 0 to 60 miles per hour in 5 seconds. It's a quite a demanding requirement. It has to be a strong muscle car that cruises on the road to get into 60 miles per hour in 5 seconds. This is the requirement. So now with these requirements, the designers are sitting on the board. Well, this is what is our requirement. So the speed will have to be this. For that, the engine has to be this powerful. The size of the engine could be this, with automatic transmission or manual shift. and hydraulic system and whatever mundane things. So all these are taken into consideration. And finally, designers are now working on the concept which was abstract in some kind of imagination into a real form, which is this car, which is Dodge. And this is a vehicle considered to be one of the fastest pickup to take 0 to 60 miles per hour in only 5 seconds with a top speed of 157 miles per hour. So this is how a concept will be given into a product. Now we'll talk about other elements involved in designing. So let me explain the design from the concept. The requirements came from the customer who wants a two-story villa with a front balcony, 3 bedrooms, and a living room, attached baths, kitchen on a 50 by 50 land area, and in the building, inside the villa, there will be inside stairs, including a boat landing to the adjacent lagoon. And of course, there is landscaping with a front garden. That's the requirement. So, this is the kind of requirement. So, it will be two-story villa. Now, the designers are sitting and started with these inputs. They are now plotting those requirements into kind of an AutoCAD or whatever drawing calculation. They are designing the structure here, the layout, and all those kind of things. So this process is actually design and development process. Now look at what is all involved in design. Now design has got a verification element. So what is verification? Verification is a confirmation through the provision of objective evidence that specified requirements have been fulfilled. So there are certain specified requirements. So you have seen in the earlier picture, someone is verifying whether the requirements, there are 3 rooms required. Yeah, there are 3 rooms. There's stair inside, it is there. There's a front garden, it is there. There is a balcony on the top in the front, upper floor, it is there. So the specified requirements are being fulfilled. That is called verification. Now, what is review? Review has got some kind of interdepartmental or cross-functional involvement here. Let's see what is review. Review is determination of suitability, adequacy, and effectiveness of an object. Object is the house itself to achieve its established objectives. So the house, the villa was designed for certain purpose. Now, whether the object is going to achieve those things, is there 2 rooms or 3 rooms, kitchen, and all those kind of things. So review is determination of suitability and adequacy and effectiveness of the object. The building has got the features to meet its objective. The objective of the house is to stay for a residential purpose or whatever purpose. So that's review. What is validation? Very important definition. Validation is confirmation. It's a confirmation process through the provision of objective evidence. So you have to have objective evidence. You seek objective evidence, some record of activities undertaken, that the requirement for a specific intended use or application has been fulfilled. So validation is always by an actual test or putting the object into service. If the building was not strong enough, that would have collapsed. That would not have stayed on its foundation. And the building is strong enough to withstand the wind force, the seismic conditions, and all other conditions based on which that has been designed. So therefore, validation is always by actual tests. That, of course, you have done review, you have done verification, but validation is going to prove that it is going to stay without doubt. So what happens is the casting process, the slab casting, the RCC castings, the mixed designs tested for compressive strength, and for example, within 21 days, this much crushing strength, compressive strength, it should attain, whether it is attaining, and what is the compressive strength of the slab is tested before, and based on that, the casting is validated. That is called special process. So you have done the validation. So validation is always through confirmation. So once the compressive strength is perfect and meeting the requirement, you say that the mixed design, RCC design, is validated. And if that is validated, the building is going to stay on its foundation and all the structures. Now, what is the requirement of a design? That it has to have a plan. I'm giving an example of a company that I'm quite emotionally connected. This is one of the oldest company in India where I was fortunate to work and serve. The company's name is Jessup. The company's name is Jessup and Company. If you look at the logo, it's a phoenix bird. In fact, I was inspired to take TCB's logo from Jessup. It was my second company. I joined in 1987 when this company was celebrating bicentenary, 200 years. This company was established in 1787. So this is one of the design plan. I do remember I was involved somehow in the manufacturing process for this crane, which was an EOT crane, a 160 ton by 50 ton auxiliary waste crane with planetary gearbox. This was for ladle handling with 20-meter span for ISCO. Jessup was known to be the company that makes everything first in India. Jessup was synonymous with crane and road building equipments and so on. So I'm taking this example because of my emotional connect. Unfortunately, the company is closed. Now, it's very painful. It was an ocean of knowledge. And there are many cranes in India still operating after 50 years or 70, 80 years designed by Jessup. So I've taken this from that unique product that I was part of manufacturing. I was not a designer. They were exceptionally good designers. So this is the plan for that. So how a crane is made, EOT crane will have box girders, which is a box structural member. It has got end carriage. So those things, and of course trolley, those things will be designed. So design calculation. So first of all, one of the activities, the box girder design, the end carriage design, and say Blesson is the designer. And verification will be done by DR Lokhande, and review will be done by DR Lokhande and BCBA, and of course customer can be involved. These names I've given because I love these guys. They're my colleagues. All right. And then who will approve? Say I'm having an experience in crane, I am the designer. I'm going to approve this. A stands for approval, and also customer will be approving this box girder design. And we are using ASME code and IS code and also customer's requirement. And the time was given that you have to finish it in 10 days. So there are several designers sitting together and doing it. So in 10 days time, there'll be a start date and end date here. The trolley, waste and gearbox design, Ajay Sridharan, another good guy close to me. And again, he is involved, for example, in designing this. These are the verifiers and reviewers. Electrical system design, BC Babu, another colleague of mine. She is an electrical engineer, so she is responsible for doing this. And then the verifiers are these people, and you have got ASME and other standards. Again, 10 days given. Now, mechanical component design, which is gearbox and waste and the sheaves and the rope arrangements and all those things, will be Ankit Srivastava, another brilliant engineer. He is going to do the design of the mechanical components. Is a great mechanical design engineer. Again, review will be done by MSR and the customer, and like that again 10 days given. And then welding design. Pradyumna Kumar is one of the brilliant welding engineer and structural designer. So he is the one going to design the welding component of it. And MSRA will be the verifier, and the approver will be again the customer, because welding process needs approval and stuff like that. Again, ASME codes are used, and also American Welding Society code. It will be 7 days time is given, and this will be done once the box girder and everything is orientation is done, the span is known, welding design will be done. So welding design can only be done once the box girder and the trolley and waist is already. In other words, the whole design should be completed in 15 days time. Because 10 days will be for the box girder, trolleys and all, and then welding will be designed. So these kind of a plan will come. And what is the output of the design process? You'll have drawings, you will have technical specification for the materials and so on. So you will expect such kind of a plan. Now, it is not necessary that every organization is required to have this kind of a plan for doing the design. It could be system itself will prompt. There are a lot of companies are using SAP and other softwares. So there may not be a plan exactly like this, but the concept is this, that there'll be someone who is responsible to design, verify, review, validate, and also approve. And someone will be responsible to look at the changes in the design and development process. So this is how designs are performed. Let me show the design process. These some of the sub clauses of design element is design and development planning. I have shown you a plan. Design and development inputs. Definitely you need inputs. Design is a process, I have explained. So you need inputs. You need source of inputs as well. Of course, you need controls, the review, verification, validation, approval. These are all controls. Then outputs, design and development, you will have output. And this output could be in the form of whatever we'll see now. And of course, design and development changes. Now, what the standard requires, all records of inputs, of verification, validation, review are retained as documented information. So this is how you are going to ask. So can I have a look at your design inputs and where you took it from? All right. And also design validation record, design verification records, design review records. Now, several records can be combined. Design review and verification can be done together. Validation could be a separate activity. So some activities can be combined. Some activities can be performed separately. Now, this chart is very, very important. This is how the process is defined. Process typically will have activities, chronological, logical activities that converts these inputs into outputs. And the inputs will have sources of inputs, and outputs will go to the receiver. And for each of these elements, sources of inputs, activities, and their output all will have controls. So now design process is basically a process where design inputs are converted into design outputs. Of course, there'll be starting time and end time to complete those process activities. This is the basic definition that I have given. Now let's see what kind of inputs and what kind of information we need. First, for the sources of inputs, you get it from a contractual documents. You will get national or international standards or codes. For building codes, AISC codes, those kind of codes are available and you are going to refer. There could be some kind of company's own handbook as well. So customer requirements are coming as inputs. Without knowing customer requirement, you cannot design any product. So you need to have customer requirements. So handbooks, for example, one of the company, we are regularly auditing their massive structural engineering company, and they're doing pre-engineered buildings. They make pre-engineered buildings, very complex buildings. They make, so they've got their own handbook. All right. So they have got code requirement, AISC code, the structural codes are used, their handbooks are used. These are all inputs. And then activities. First, activities, prepare a design plan. And based on that, you start design and development process, calculations, preparation of the drawing. You remember the drawing? There was some AutoCAD drawing or things like that. Design calculations were happening, right? You can take inputs even here. One of the inputs could be seismic data, geological data. All those kind of things are to be taken as input. So you have got sources of inputs, and then you are doing activities to get the output. And this output is in the form of drawing, data, and final design, right? You got the design and you got the BOQ, bill of quantity, how much of material, what material, how much quantity, and there of course the technical specification for the material. So these are the output from the design process. Now, as I said, there'll be controls. So design and development review is one of the control. Design and development verification, another control. Design and development verification, another control. All those kind of things will give you output that goes to the production department who is responsible for manufacturing, that is the successor process. It goes to the project team because project team needs the drawing for managing the customer relations and procurement activities and so on. You will have purchase team who is responsible because they buy the material based on what the designer told them to do in the form of design specification data sheets and so on. So this is how the whole process really works. I hope and the exercise and the discussion was quite easy to follow. So when you start auditing, you start with an opening question. Can you please explain me your design and development process? Oh, this is what you do. Can I have a look at the plan? And you see when, what activities will be done, who is responsible for that, and whether there is a timeline for various activities logically being done, and whether this design plan has been followed throughout to produce the drawing, design, development, calculation, whether the responsible parties were involved in the verification process, is there verifiable records, which is objective evidence of design input, design output, design review, design validation, all design changes, all those things are to be checked, are to be verified. So you can ask, can I have a look at the design review records? What kind of review happens? What kind of verification happens? Well, the verification and review are done together. It's fine. So who is responsible for that? Look at whether the person, it is not the name, it could be the function, responsible function. Maybe the design manager, whoever is responsible to, approve the design and the drawing. It sometimes it goes to the customer. Sometimes it goes to the consultant hired by the customer, because customers sometimes do not have the right knowledge and competence. They are the user of the product. Now, many a time, the consultants are hired by the customer to act on their behalf. So maybe the consultant on behalf of the customer can approve the design and the drawing. So once you have done this, you know that yes, there is a plan and they have implemented the plan. There are inputs, outputs. You can see the validation results of the building, or validation results of the cube mix or concrete mix or slab casting designs and so on and so forth. And then you are happy with it and all records are available. You say, thank you so much. You are doing wonderful job and all records are available. So look at the process flow. Look at the input, look at the activities, look at the logical sequence of the activities, look at the controls, look at the output, and whether this meets the requirement of the customer. That's how design process can be audited.